Welcome back again in Algebra 1 and our lessons in Algebra 1. After we have discussed the relations in the previous video, today we will discuss inshallah the functions, what I mean by a function. In brief words, I can define the function as a special type of a relation that pairs each domain value with exactly one range value. With exactly one range value, I need to put two underlines here. Okay, let me clarify that by an example. If I had defined a relation, this is a relation, f, I've named it as f. The x values or domain values are 2, -2, and 1. And the y's value, which is also the range values, are 5, -3, and 3. Now, if I apply this definition, we can note that 2 is just related with 5, and -2 is just related with -3, and 1 is related with 3. And if I represent it by any type, by any way, by the ways to represent a relation here, tables or mappings or the rules or the graph, any way of these ways, in all of them we will find that my definition is applied here, where 2 just related with 5. There is no other number related to 2 from the range. Just 2 is related with 5. And -2 just related with -3. There is no other number related to -2 except -3. Same way here, 2, -2, and 1. Every one of these numbers is related with one number. Okay, I want to give some example here, counter example, to see you how when our definition is not applied. If I give you a mapping like this one, and I need to put numbers like 2 and 3, and another, this is my domain, and my range I want to put it as 3, 4, 5, etc. So if I draw an arrow from 2 to 3, and from 2 to 5, another arrow from 3 to 4. This is a relation represented by mapping method, mapping way. So this is the domain, which is x, this is the range, which is y. So this is a function or not? My question now, is this a function or not? Of course, this is not a function. Why? In my case, the relation to be a function, we need every element in x, every element in the domain, related just with one element in the range. But here 2 is related with two elements here, 3 and 5. So if we see double arrow, they are going from the same point here, which is 2 in the mapping graph, mapping diagram, directly. We noted that this is not a function, so this is not a function. Okay. Another counterexample. Now, assume you're given the graph, like this is 1 and this graph. Now, this is a function, I want to call it f of x. This is a function. Is this a function or not? Is this a function or not? Now, to check if this is a function or not, take arbitrary x here, any x here. Look for this x and the x-axis. You will find it's related by two y's. This is y1. I will call it y1, which is here. And related with y2, it will be here. So my x here is related to two y's. So this is not a function. Good. There is another way we can use the vertical line test. Vertical line test, when we see the graph, we use the vertical line test to check if the graph is function or not. What I mean by vertical line test, I will put imaginary line, vertical line like this one. I will make it as imaginary one. If the line intersects the graph in 2 points or more, so directly the graph is not a function. So any vertical line like this is fine. This imaginary vertical line intersects this graph in 2 points, so directly this is not a function. So when we conclude that this is not a function, because it's not a function. Good. Let me get back to main example here, which is a function here. This is a counter example, and some relations they are not a function. So if we have 2 and -2 and 1, 2, -2 and 1 as a domain, 5 and -3 and 3 as a range. Good. We can represent this relation or this function. This is a special case of the relation represents a function, because we have every element have just only one image or only output. For every input there is only one output in the range related with it. Now this is a graph. Later inshallah, later we'll know that this is a linear function. We call them linear function, and we will learn how we can find the rule and construct the rule of the function. If we have some numbers, how we can construct a rule or building our rule. So this is a rule of the function, 2x plus 1, and how we graph the functions. All of these we will learn them by the next lessons. Okay, this is a graph of my function here. So if I draw a vertical line in any way on the graph, let me put a vertical line here. You will find it intersects the line just in one point. So of course this is a function by using the vertical line test, by using the graph. There is one row related to every number here. So also is a function by a mapping, by a table. There is no repeated values in the domain. That's good. So that we need to learn today. That's all of the thing about the function, except something I want to know it here. If I ask you now, if I give you the rule, for example, let me use this one. Assume I give you the function, and the function is given, and I ask you to find the value, the output values. For example, assume f of x is equal to 2x squared plus 1. And I ask you to find the value of f of 2, which means the image of 2 under our rule of this function. The rule of the function is 2x squared plus 1. This is the rule of the function, and we can call them, we can replace f of x by y. You can use y or f of x as you want. So if I want to find f of 2, that means the image of 2 under this rule, we need to substitute just 2 in place of x here. So if we replace it, we will get 2 times 2 squared plus 1, which equal the period for the bracket, so 2 squared, which equal 4, 4 times 2, which equal 8, plus 9, plus 1, which equal to 9. So f of 2 is equal to 9. Again, another one, f of -1. How I can find them? The same procedure, we can substitute the -1 here instead of x. So 2 times -1 squared plus 1, we will get 2 plus 1, which equal to 3. That's how we can evaluate the functions. We call this procedure evaluating functions. Evaluating at some specific number. I ask you to find the value of it. That's everything I want to show you today. Our lessons function. I want to make my video is small and to make it clear for you. So consider this lesson as an introduction to functions, and we will continue later, inshallah, step by step. See you later in next video. Goodbye.